find the area of the region enclosed by y equals x squared and y equals 2x minus x squared. Yeah.
Say there's an instance where the graphs overlap, and so at some point within your bounds, the different ones on top, we split into two.
Yes, and we're going to do that in a little bit. Exactly. Okay. So this setup is a little bit different than the last problem. If you look back at the last problem, they gave me values of x. I said x was between these two numbers, 0 and 1. But I don't have that going on here. They just tell me I want the region enclosed by these two functions. I need to know where these two functions intersect in order to find my region. So your first step in this problem is to find intersection points, okay? I mean, I know what these graphs look like. The first one is x squared, it's a parabola facing up. The second one, there's also an x squared, but there's a minus in front of the x squared, which means it's downward facing parabola. But I need to find where these two functions actually intersect in order to graph my region. So if you have two functions and you want to find their intersection points, how do you do that? Set them equal to each other. So let's do that. Say x squared equals 2x minus x squared, and you're going to solve for x. So I'm going to add x squared to the other side. I get 2x squared equals 2x. Right here I can see that there's a coefficient of 2 in front of all of these, so I can divide by 2 just to make my life a little bit easier. X squared equals x. And subtract it to the other side. X squared minus x equals 0. And you factor. What can I factor out of that? An x. X minus 1 equals 0. And I get two solutions. I get x equals 0 and x equals 1. So these two parabolas intersect in two places. They intersect at x equals 0 and x equals 1. So I'm ready to start looking at my picture now. I know for my graph, which I don't need so much down here. I know for my graph, I'm only going to look between 0 and 1. Let me do that over here. Okay, so let's take our two equations. The first one, y equals x squared. If I plug in 0, I get 0. If I plug in 1, I get 1. So this y equals x squared, we know what it looks like. It's our parabola centered at the origin. And then my other graph, my other equation was y equals 2x minus x squared. So I know that 2 points on this new graph have to be these 2 points at 0 and x equals 1. Because my two curves intersect there. So all I've got to do, this is kind of the hard part. You know that they intersect at these points. You need to know which function is on top and which one's on bottom. Right? To set up that integral, I need to know which one comes first, which one comes second. So you have to pick a number in between 0 and 1/2 and see which one gives you a bigger value, 0 and 1, and see which one gives me a bigger value. So let's say I plug in 1/2 into these. So if I plug in 1/2 for x into x squared, I get 1/4. And if I plug in 1/2 into the other one, 2 times 1/2 minus 1/2 squared. 1 minus 1/4 or 3/4. So it looks like my second function has a bigger y value at 1/2. So that means it's going to be on top of the other function. So it'll look something like this. Okay, it's on top. So this one here is the negative 2x minus x squared, and the one on the bottom is y equals x squared. Okay. And it doesn't matter, I plugged in 1/2, you could plug in a 4th, whatever number between 0 and 1, and figure out which one has the bigger y value, so you know which one's on top and which one's on bottom. Okay. All right, we did all of this work just so we could get a good picture, but the picture is pretty important. The picture tells you how to set up the integral. So I've got my picture now. I want to set up my integral. I hate to scroll too far away from our picture. Okay. So I'm going to integrate. What are my, what's my range on my x values? Looking at my picture. In my region here. 0 to 1. So when I write the integral down, I'm going to write integral from 0 to 1. And then I need to know, oh, don't do that. Which one's my top function? So that one's going to go first. So I'm going to put 2x minus x squared, and then minus the other function, which was x squared. Dx. Okay. And what I would do if it was me, right now we have 3 terms to integrate, but 2 of these are x squareds. So just go ahead and combine it, because that's going to mean that you have less numbers to plug in later. So simplify if you can. This is 2x minus 2x squared. And what do I get when I integrate that? What do you get when you integrate 2x? X squared, and then 2x squared. 2x cubed over 3. Okay, we're just doing our reverse power rule where we add 1 to the power. And then I just gotta plug in my numbers. So 1 minus 2/3 or 1/3. And again, you should end with a positive number, not a negative number.